In this video, I want to demo an example of a query interface created with SPARQLing for querying a domain-specific ontology. Our example ontology is protein kinase ontology, or ProKino. I have to mention that such a query interface created with SPARQLing is designed for users who are familiar with the domain of knowledge but are not familiar with SPARQL. The SPARQLing interface starts by displaying the overall layout of the ontology schema, or a fragment of it, as a graph. Each class is shown as a rectangle and is linked to other classes with arrows which represent the object properties. If you click on each of the classes, more information about the class would be visible, including the list of the data properties and also the class hierarchies. For example, the motif class has two subclasses, structural motif and sequence motif. Selecting each subclass would enable or disable a set of data properties accordingly. It is also possible to create more than one instance of a class by clicking on the plus sign besides the instance field. Now let's create a set of example queries. The first example is to find the gene name, wild type, position, and the mutant type for all missense mutations occurring at pKa position 95. The query requires us to select gene class and mutation class. For the gene class, we create the first instance. And because the query is looking for all the gene names, so we select it. We are done with the gene class, so we add it to the query. As you see, the triples are added to the panel. Now we want to work on the mutation class. We create the first instance of the mutation class. The query was looking for missense mutations, and it was looking for wild type, mutant type, and position. For the pKa position 95. We are done with the mutation class, so we add it, and the triple patterns are added to the panel. The last thing that we need to do is to connect these two classes. So I click on the link has mutation, and the triple pattern is added to the query. Now I'm done with the body of the query. I click on build and execute. Now I have the complete query, including the prefixes. Now I need to execute the query, and here we go. We built a SPARQL query without writing SPARQL query. The second query is to find the counts of wild-type arginine missense mutations for each kinase gene. Based on the query, we need to work on the gene and mutation class. From the mutation class, we need to specify that the wild type is arginine, or R, and it's a missense mutation. But from the gene class, we need to specify that the counting of wild type would be grouped by the gene. So from the missense mutation, we need R. From the gene class, we need to specify that the counting of the result would be grouped by gene name. And again, we need to connect these two classes. Build and execute. and we get the complete query. And by default, the result is ordered by descending and execute. So we get the list of the gene name and the counts of the wild type arginine. The third query is that for each gene, find all missense mutations, wild type, mutant type, and position located in the R spine, which is a type of structural motif. So from the query, we need to work on three classes: gene, mutation, and motif. From the gene class, we need to create the first instance and select the gene because not a specific gene is specified. Now we are done with the gene class and we add it to the panel. From the mutation class, we need the missense, and the query is looking for wild type, mutant type, and position of the mutation. And from the motif class, we need to create the first instance and select the structural motif. And from the motif name, we need the regulatory spine. And add it to the panel. Now we have three classes and we need to specify the path which connects these three classes. We can select this path and the triples are added to the panel. We build and execute the query and execute, and here we go. We have gene name, and for each gene we have wild type, mutant type, and position of the mutation located in R spine structural motif.